Hi, everybody. Thank you for joining us back here at Virtual Farm Science Review. Right now, I have with us Harold Waters, OSU Extension, and he's going to talk a little bit about nitrogen management in corn. Harold, you often present on the best nitrogen rate to apply for corn. And sometimes I hear you say, why not zero? What do you mean by zero? We need nitrogen to make our corn crops grow.
Oh yeah, we need nitrogen to make the corn yield, probably to our highest economic level at least. But what I tell farmers is I'd like to see a strip of zero across their field and maybe even across multiple fields so they know how much their soil is actually providing. I think most of us think that it's linear, at 0 pounds of nitrogen, you get zero yield, and at 200 pounds of nitrogen, you get 200 bushel yield. That's not the case. And depend on your site and your soil and how much water you have and probably a lot of other factors too, a zero can sometimes yield pretty darn well. And so I'd like a farmer to know what his soil is capable of before he tells me he needs 200 pounds of nitrogen.
So, what is your recommendation, or what is the nitrogen rate based off of here in Ohio?
So in Ohio, we use a corn nitrogen rate calculator. And that goes back to the probably 2005, 6, 2007, somewhere back in there. 7 universities across mostly the Eastern Corn Belt, but much of the Corn Belt went together and came to the conclusion that economics, yield, background of research and yield, but economics of corn price and nitrogen price is probably a better way to decide on nitrogen rates rather than a yield-based goal. And so they put that into effect, and that is Ohio's current nitrogen recommendation tool. It's the corn nitrogen rate calculator. If you Google that, or you can find it, or you can see the website here on the screen, cnrc.agron.iastate.edu. That means this tool is housed at Iowa State University, but it's our data that's the backbone for what you get for recommendations here for Ohio. And again, we have data going back into the mid 2000s, so more than 10, more than 15 years now that we have data in that to help us set a nitrogen rate here for Ohio. But it's based on economics.
So, what have you and OSU Extension been doing to continue to build that tool and ensure that we have the most economic nitrogen rate for producers here in Ohio?
So the corn nitrogen rate recommendation tool is based on Ohio data, and we use farmer trials, so nitrogen rate trials on farm. Probably about 65, maybe 75% of the data that's in the database comes from on-farm data across the state of Ohio. And then three of us, many county educators, but also Greg Labarge and I have been doing these nitrogen rate trials at the research stations. And we've continued those actually since 2005, I think. And a goal is that we would follow the trends from year to year. And we are seeing some interesting trends, which is why I kind of like to talk about why not a zero. Most farmers, when I talk to them and I suggest maybe we have a strip across the field with zero nitrogen, they don't like that suggestion. And so it's a bit of a squeeze, whatever, to get that done on farm. And so if we do it at the research stations, we can certainly do it there. We know that economically we're not going to break the bank on a research farm in a small plot particularly, but we gain that data. And what we see is that from year to year, lots of variation.
So, with the work you've been doing down at Western Agriculture Research Station there at South Charleston, what have you been seeing that we're actually getting from the soils there, and what results are you getting out of those nitrogen trials?
So I'll roll up my screen here a little bit more so you can see my nitrogen rate trial data. And so this is all the data points. This is not averaged by year. This is not averaged by rate. This is all the data points. I think there's around 16, maybe 1,700 data points in that little set right there. And this, I've got, at some point I'll add 2019, and then this year I'll add 2020 to the database as well. But I go back to 2006. So this is my corn after soybean chart, and that's why it starts in 2006. My first trial in 2005 was actually corn after corn, and I do have corn after corn trials since then as well. But anyway, so 1,800 data points, and across the bottom you see I've got 0, 50, 100, 150, 200, and 250 pounds of nitrogen. So I cover the gamut, you know, the top to the bottom of that. But what's really interesting, and I've talked many times with the manager, Joe Davlin, there at the Western Research Station, but also with Greg Labarge, who's conducting similar trials at the Northwest Research Station, and with Matt Davis up there, a discussion with him about what this zero can do. And you can see here on my range, I've got a 70 bushel per acre on the low end to 176 bushels per acre on the high end. That's with zero nitrogen. That means that is what the soil mineralized in that year, in that date, in that location to provide nitrogen for corn, because corn needs nitrogen and you can't grow it without it. And so the soil supplied that. And I think as a farmer, I am one myself, and Jason, you are too, we need to know, you know, what that soil is capable of. I think we also need to know that range. I mean, that's a 105 bushel range, basically in the same field. I rotate corn and soybeans at opposite ends of the field. So one year I have corn there, next year I have soybeans, etc. So this is in the same field on the same farm every year since 2006. And then I've got a little note over here on the side, how much nitrogen do we actually mineralize? And so I do some assumptions here, but I estimate that we get 0.7 of a pound of nitrogen per bushel. So I simply take the yield, so 176 or 70, whatever. And we've got a range of about 50 to 125 pounds of nitrogen that we mineralized each year. And most of us, most farmers in Ohio, just assume it's zero, but it is not zero. That 50 to 125 is certainly more reasonable. Northwest Ohio, the Hoytville clays that Greg does his work on, it's about, 15 to 20 pounds less, but it's in a similar range. So his may go from 35 up to 105 or something like that as far as what nitrogen he says mineralized. And we see around the state some other trials where we collected this kind of information, and we see the similar numbers across the whole state of Ohio.
Very interesting that we can have a 100 bushel swing in corn yield without applying any nitrogen at all. So how do we determine if it's going to be a year where we're going to get 70 bushel out of zero or 170 bushel out of zero? Are there any tools available to help us maybe decide how much nitrogen to put on after our soil mineralization?
So the first answer to your question is we don't know until the end of the year. We do have some tools where we can make some guesses, and I'll talk about those in a second, but I think that we need to understand that in Ohio, particularly, maybe slightly different than certainly the central or western part of the Corn Belt, we're going to have this huge variation. Just keep that in mind. So tools, yes. So we have done in the past, 10 to 15 years, we've pulled soil samples and tried to determine how much nitrogen is mineralized based on the organic matter, or how much nitrates are in the soil at the start of the growing season. What I find, and Greg has seen the same thing, we have somewhere between 8 and 11 parts per million of nitrate in the soil at the start of the season, where we have after a soybean crop. And that's pretty normal. We don't see that change very much. If you come in after alfalfa or after manure, certainly that's going to look different. And that's why the PSNT, another tool, pre-sidrous nitrate tool, can be used. But it really only works well if we've had alfalfa that we've plowed down or manure that we've incorporated to actually get some idea of how much nitrogen we have or how much nitrates we might have for use for growing corn. A tool that I've been using, I think it's a neat tool. It's quick and easy. And I think most farmers, it's not that we want quick and easy, that's the time we have. So my Ndvi tool, I use a green seeker from Trimble, but it's an Ndvi tool, and there's a lot of Ndvi tools out there. But what it does is it gives you an understanding of the greenness of the plant and how robustly it is growing. So it basically measures the size and the color of the corn plant. And you can, for $500 or less, you can buy one of these green seekers. Again, there's others out there from other manufacturers. Walk across your field and get a pretty good idea of, number one, the variability across the field, but also get you some idea about how likely that plant is to do well throughout the rest of the growing season. But that's where when the zero comes in, we kind of need that zero nitrogen rate out there to make that comparison on the low end, to start then building some calculation in our head, if not on a piece of paper, to start saying, okay, zero gives me this, and this is my plant size, and 200 pounds maybe on the other end, so we have a nitrogen rich strip out there. And so we make some comparisons, and then we say, okay, how much nitrogen we need to bring that up to this? And then that's where a tool like an NDVI comes in. But, and this is the but, I've been using the NDVI tool now for 6-7 years, something like that. It's been a while. It's not the perfect tool. In years like we've had in 2017 and 2018, a little bit in 2019, it was very hard to determine differences between 0 and 250 pounds of nitrogen because we were mineralizing a lot of nitrogen. This year, we went into that dry period in June, mineralized nitrogen actually dropped off. And so in a year like 2020, I think it's going to take a pretty high nitrogen rate actually to maximize our corn yield, or timing and placement could offset some of those issues. So crop sensors, we also need weather information. We need to have some understanding of field variability. Many of us has our soils maps. We now know that those soil maps have some variability that isn't quite explained on the map. And that's why I'll back up just here up a little bit to show you this map. So this is an organic matter map that I made with a farmer. He made it for me, actually, I should say. So he uses precision planting, smart firmers, and again, there's other sensors out there that will map organic matter. So this is an on-the-go map right off the back of his planter as we were planting the field. And so now we have an NDVI of this field. We have a zero rate out in this field. We have this organic matter map, and we have some understanding of the weather. And so we can put together a recommendation based on those tools. The problem is, it still isn't perfect. It still gets us maybe a little bit closer to that rate where we'd like to be, but it doesn't necessarily get us all the way there. Just does things a little bit better than we can do with nothing, or with just a seat of our pants recommendation. And so we try and put all those tools together, and our head, our experience, the calculator between our ears. What is it? One of those sayings is the biggest drawback to improving productivity is the calculator between our ears. Sometimes it has a bias. And so that's why we need some tools to kind of bring in some additional information.
Excellent. It sounds like there's a lot going on out in our fields with nitrogen. It sounds like Ohio State is really looking at ways to help us as farmers do a better job of managing nitrogen, better understand what rates we may need across our field in these muddy waters where it's not a nice, straight, linear response. So what's your take-home message to a farmer that wants to try to do a better job of managing nitrogen on their farm and maybe wants to look at a few different rates and try to figure out where his farm actually falls?
So number one, our number one recommendation in Ohio is still use the corn nitrogen rate calculator. Again, based on Ohio data, based on corn price, based on nitrogen price. That's going to get you pretty close. Of course, the concerns are environmentally, and you talked about muddy in the waters, and yes, nitrogen in the waters too. Environmentally, we'd like to do a better job than an average, and that's what the recommendation tool gives us, an average across the state of Ohio. And so that's where we can do perhaps some adjustments based on soil types, organic matter, the weather, the year, things like that. And so it takes some experience, maybe an NDVI tool, maybe working with your local county educator. I think we've got NDVI tools probably in the hands of 15 or 20 of the county educators out there now. And again, running that across the field gives you some more understanding of what might be out there as far as nitrogen availability in this year. And then rate trials. I love rate trials. I don't think they're the end all, do all, but they do give you a farmer some understanding of what they have on their farm. So I'd like to see a zero in there. I think 50 or planter nitrogen, maybe you're putting on 40 to 50 pounds of nitrogen with the planter. That's a rate. So 0, 50 pounds, let's say. I'd like to see 100 pounds of nitrogen rate. As I show on my chart here, once I get to 100 pounds of nitrogen, so this is an addition, 100 pounds of nitrogen above my 0, I'm starting to level things off at the Western Research Station. And that's a soil type that's very widely available or widely seen across West Central Ohio. Crosby, Brookston, Miami, things like that is what we have in that field of mixture. So 100 pounds of nitrogen, so we've got a 0, a 50, 100. Our current recommendation is around 175 pounds of nitrogen from our MRTN, our corn nitrogen rate calculator. I'd like to see that in there. And then something like a 225 to a 250, so I know what the upper end is, so I can actually do a quadratic analysis on that field. But if you have those 4 or 5 rates, I think you're going to come to some good understanding of what nitrogen needs are from your corn in that year and what economic levels are. But that's 1 year. And as I've tried to point out, the lots variable from year to year. So you need to build, I think what Bob Nielsen at Purdue says, you need to have about 3 to 5 years worth of nitrogen data under your belt before you really ought to be making your own recommendations. So do that for 3 to 5 years in maybe 4 or 5 fields over that 3 to 5 years. I think you're going to have a better understanding of nitrogen needs for your corn.
All right, thanks for joining us, Harold, and thanks everybody for being part of this Farm Science Review. If you have further questions, don't be afraid to reach out to Harold at waters.35@osu.edu, visit your county extension office, or follow the corn newsletter, which is at corn.osu.edu. That comes out every week in the summer, and it's an excellent resource for you to stay up to date on the latest information from OSU Extension.